Today we're going to look at proving triangles congruent. To do that, we're going to look at 4 specific postulates that are used frequently to prove that triangles are congruent. The first one is the SSS postulate, which is side, side, side. It says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So looking over here, by the side, 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 I have these sides are congruent, these sides are congruent, and then these sides are congruent. Triangle A, B, C, so following the sides 1, 2, and 3, A, B, C is congruent to F, G, H. So that's side, side, side. So if all 3 sides of a triangle are congruent to all 3 sides of another triangle, then the 2 triangles are congruent. This is different than having to prove all of the pieces congruent. In the next one, it's side, angle, side. So if 2 sides and the included angle, that means the one between the 2 sides of one triangle, are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So again, that's saying that this one and this one are congruent. For the included angle, it has to be this one. So this angle and this angle are congruent. So by side, angle, side, SAS, so side, angle, side, triangle ABC is congruent to F, G, H. And notice when these are being drawn out, that they're being drawn in a way that you can easily find the corresponding pieces. Sometimes the pictures are not that way. Okay, the next postulate, which you only have to show 3 of the 6 congruencies, is angle, side, angle. So if 2 angles and the included side of one triangle are congruent to 2 angles, and the included side of another triangle, then the triangles are congruent. Okay? So, 2 angles in the included side. Well, so if this has to be included, it means that these 2 angles have to be congruent, right? So A and F have to be congruent, and C and H have to be congruent because this is the included side. So if that is the case, then by angle, side, angle, triangle ABC, and remember you're matching the markings, so F, G, H is congruent. They're congruent to each other. Triangle ABC and triangle FGH are congruent to each other. And our last postulate, that means we only have to show 3 congruent pieces instead of all 6 for a triangle, is the AAS postulate, which is the angle, angle, side. So if 2 angles and a non-included side of one triangle are congruent to 2 angles, and the corresponding non-included side of another triangle, then the two triangles are congruent. So this angle, side. See how this is not included? The included side would be this one. So the included side is the ASA, the not included side is the AAS. So, by the AAS postulate, triangle ABD is congruent to CBD. Okay, so that's all of the information for this piece. The next part is proving some stuff this way. So we're going to do some proofs. So let's say I have triangle. I'm going to prove that the triangles are congruent, and here's my picture. It says segment OK bisects angle MOT. So segment OK, this one, bisects this angle MOT. That means this angle and this angle are congruent. And segment OM is congruent to OT, so then I'm going to mark that. I'm just marking my picture so I can get a plan of what I can do, which theorem or postulate I can use to prove my triangles are congruent. So then, let's see. If I look at this here, I've got a side and an angle, and I know, let's see, so a side and an angle, so if I can find a third side, it would work. So let's see if I look at here what my third side might be. Well, notice that this side is in both triangles, and this would be the included angle if I got this side. So this side right here is the other one I'm going to use. So I'm going to use those pieces of information. Then I'm going to have side, angle, side to prove that these two triangles are congruent. So the first step is always our given, right? Step 1, OK, segment OK, bisects angle MOT. That's given. Then I'm going to say that angle 1 is congruent to angle 2 by definition of angle bisector. Third step, I'm going to say that, okay, so I have my angle. Now my side here, I'm going to have OK is congruent to OK. Why is that? Well, that's a reflexive property. And it's the property of congruency or congruence. Then step 4, I'm going to say that MO and OT are congruent. Why am I saying that? Because it's my given up here. And then step 5 says, well, I have my angle and my two sides. So my two sides of my included angle here. So I'm going to be able to say my triangles are congruent. So triangle MOK is congruent to triangle TOK. I've got my triangle there because of the side angle side postulate. Okay, so let's do another one. Again, it's the best thing is to mark your picture and map out a plan first. So segment BA is perpendicular to segment YZ. That means that this one and this one are both right angles. And segment BA bisects YBZ. That means these angles are congruent. So I need to prove that the two triangles are congruent. Well, I have an angle and an angle. So looking at my piece over here, I could do a couple of different things, right? I could do, well, no, wait. Let's look at it again. I have two angles. So I can do two angles and an included side, or two angles and a not included side. So then looking at my sides, what can I prove? Well, I don't know a relationship here or here. It doesn't say it's a perpendicular bisector, so it doesn't tell me that those are the same size. But I know that this is the same size as itself, so it is congruent to itself. So that's my side. So I have angle, side, angle is what I'm going to prove. So to start with that, I'm going to say that segment BA is perpendicular to YZ because it's given. Then I'm going to say that angle 1 and angle 2 are congruent. because they're perpendicular. Probably should state that they're perpendicular. Angle 1 is perpendicular to angle 2, or angle 1 and angle 2 are perpendicular, or are 90 degrees, are right angles. So then I'm going to say that they're congruent in the next step. So this is the definition of perpendicular. My next step is going to say that the angles are congruent because all right angles are congruent, which is one of our theorems. Then I'm going to say that segment BA is congruent to itself. So I have my angle and my side. That's going to give me, that's reflexive, the reflexive property. Of congruency. Then I'm going to say that angle 3 is congruent to angle 4. I'm going to say that segment AB, let's try that again, segment AB bisects angle YBZ, that's a given. Then I'm going to say that angle 3 is congruent to angle 4 by definition of bisector, angle bisector. And then I'm going to be able to say that triangle AYB is congruent to triangle, it's a triangle, AZB by angle side angle. Okay, so that's how you're going to do this. Have any questions, let me know.